Welcome to Dr. J's Java Modules. In this module, we'll go over files, methods, arrays, and array lists. So the first topic up on our agenda today is file I/O. So file input and output. We discussed in another module, in the fundamentals module, that when you want to persist data, you have to write it to a secondary storage device. And some cases that's using a database, some cases it's using just plain old files, but at the end of the day, file I/O is really the fundamental. So you can do input from file and output to file. So let's do some examples. I already have a project created here called Files, Methods, Arrays. I'm going to create a new Java class. This one's going to be called File Output. Let's do input first. File Input Fun. And right here, I'm going to create a main method. All right. And now we're going to import java.util.scanner because that's what we're going to use for input. This is going to be a little bit different from what we experienced when we were doing input from the keyboard. We do need to have a file for input. So the best way, or the easiest way really, to create a file from here, you could actually go into the Windows file system or whatever platform you're on and go into the project and create a file that way. But I found the easiest way is over here we have the different tabs over here, projects, files, and services. And if you go to files here, and under the files, methods, arrays, I can just create at the very top level, I just create a new, and then I don't see plain file here or empty file. So I'm going to go to other, and you'll notice all the way down at the bottom, other, and then down further, there's empty file almost near the bottom here. So I'm going to click empty file, and you can name it really whatever you want. So I'm going to call this input.txt to make it a text file. And let's put some names. So John, Ksenia, Bob, Sally, Ollie, Oliver, Shannon, let me see here, Be'alana. Okay, and let's do Samantha. There we go. There we go. And Nathan. We'll add another. Make it 10. Okay. So you've got all these different names here in the input.txt. I just created it through NetBeans. I can go over back to projects. That's the view I prefer, but these are just different views of what's going on. Services, or if you're working like with web services and things like that, files are just what it says. It's the actual file system given the top level folders, and project is kind of the NetBeans project view of the system. So if I wanted to, I could actually go under here, and if I wanted to, I could go there and work dir, and then files, methods, arrays. Go in there and you'll notice there's an input.txt. If I double clicked it from the Windows file system, you'll notice that I have it open in Notepad. So you can open it in Notepad, Notepad++, things like that. So it's just plain format. It's a regular old text file. So let's go back here, and I'm going to create my scanner. So I'll say let's say here, in file, and to actually create the instance of it, you have to do this. You have to say in file equals new scanner, just like we did before. But now here you might be tempted to do something like this, but this is not what you want, because this is going to scan the string input.txt. It's going to just read that string and scan it. You don't want that. You want there to be a file, which I can do there. You could make a separate variable if you wanted to, but most people just put, or a lot of people, I'm not going to speak for everyone, but I'd say probably most developers put this new statement inside the parentheses here as the argument to the method, and that passes in the memory address because file is a class, and it's a reference type. So that means it passes in the memory address, and then scanner's constructor grabs that memory address as its parameter and works with it. So it doesn't know what file is. It says cannot find symbol. The quick and easy way to do it in NetBeans is Alt enter, and it brings up a list of solutions to this. Do you want to create a class called file? Do you want to create a class inside this class as an inner class? You can also click this little thing over here. It does the exact same thing. So either way, we want to add the import for java.io.file, or you could have typed it, and the order doesn't really matter here. Now, a lot of beginners, especially in programming, when they see the red line get longer, they think that they made something worse. But that is not the case. That just means that we fixed something and now it can see a different problem. If we hover over, it says unreported exception, file not found exception, must be caught or declared to be thrown. The lazy student way of doing this on main would be to put throws file not found exception. And that just basically says, hey, the default exception handler can handle it. You would import this, of course, which I'm going to do right here. Alt-enter, and we import again java.io file not found exception, and everything's happy, right? It's happy, the error goes away, but that's not really what you want to do. It's okay to do it on some methods, because you may not know how a different developer wants to handle the exception, or you may not want to handle it at that time, so you can kind of pass it up and let someone handle it. But if you put the throws clause, throws is actually a keyword in Java, if you put this throws clause right on the method header for main, that usually means that you're lazy, because that's going to cause the default exception handler to handle it. Sometimes you're taught to do this when you take a beginning programming course, because it's easier than learning exception handling. But exception handling is not really that hard. So we're going to actually handle the exception. So to handle an exception, what that means is when something out of the ordinary happens, in other words, an exceptional event, we have to determine what do we do if that happens. And this is actually a way to send messages throughout the system. And sometimes it means something real bad happened, and sometimes it just means it's just a signal saying, hey, this happened and it's out of the ordinary, what do you want to do? So it doesn't necessarily mean something catastrophic happened. But this will not compile right here unless it says must be caught or declared to be thrown. So certain types of exceptions, we'll get to what types in a bit, but certain types of exceptions in Java, it won't even compile if you don't address them in some way, by either taking the coward's way out and putting throws up here on the main, or putting a try-catch around it. For my students, I definitely am going to require exception handling. All right, so file not found exception EX, and we're going to put end try-catch. I'm going to put a tab right there. Okay. So in the catch, that's what you do if something goes wrong. If it doesn't go wrong, it just executes whatever's in the try block and then skips over and then goes to the end. So at the bottom, I'll just say done outside the try catch, but inside of main. In here, in the catch, I'm going to just put error, opening file. Now, this is an input file, so it means it won't find it. You can still get this type of error with an output file, which generally has to do with, it's sometimes like permissions issues, and sometimes it's I can't access that file name because it's too long or something like that. The one thing you want to do when you open a file, so this opens the file automatically, there's no like open call, you do need to do this. You do need to close, and I usually tell my students this is put the toilet seat down. Okay, so when you're done, make sure you close the file. So close the file. If you've ever tried to open a file and the system says this is locked by another program, that's because someone didn't close it, or because the program got interrupted before it got to a close statement. So this is a good place to put the close. You could also put it in a finally block at the very end. That would be another option if it's actually open. So right here, for infile, since we're reading it line by line, I guess outside of this I'll put a string and I'll put name. I'm going to do this. I'll say while. Now this is essentially equivalent to checking until we get to the end of file. So infile.hasNext. Okay. So right here, in a language like C++, you'd say something like, usually like while not infile.eof. So while we're not at the end of the file. But in Java, we have something else to read each time, and then it will keep iterating. So you move the file pointer as you read things. So name equals infile dot, and we know we're reading strings. So next line. And then all we're going to do is we're just going to print them out as they come in. So pretty simple. We're not doing anything wild with this file, just to demonstrate how to work with it, basically, right? So let's run this. Right-click, Run File, and you'll notice it does, in fact, show all the names. John, Ksenia, Bob, Sally, Ollie, Oliver, Shannon, Bellana, Samantha, Nathan, and then it says at the bottom, done. Right? Pretty cool. So that's how you read from file. It's very, very simple. That's the simple text file I/O. And now for file output fun, I'm going to right-click here, Java class, file output fun. And it creates this file right here, and we're going to say import java.io.PrintWriter. I can get it to PrintWriter. There we go. And in here, the public static void main, we're going to write something to file. So in this case, I'm going to create a PrintWriter. PrintWriter, PW, equals new PrintWriter. And this time you can actually pass a string to it saying what's the name of the file. Output.txt. And at the end, of course, though, you want to put the toilet seat down. So the other problem, though, here, actually, let's do this. I like keeping it separate in this case. You have the same issue with the unreported exception. So it will not compile unless you acknowledge the exception. So I'm going to put the try statement around that, and then put a catch for file not found exception. Name it EX, right? And exceptions are just instances of a class. They're just generated differently by the system. So they are objects. File not found exception, add the import, and then print out cannot find file. So we can determine what's causing that. Oh, pw.close needs to go inside here. And also outside the try catch, we'll just put another done at the bottom. Good? Okay, so now it's really simple. Once you set it up, you have the variable here. This does not create an object of type PrintWriter. That creates a variable capable of holding the address of a PrintWriter object, right? It does not create the object. This line creates the PrintWriter object, all right? And it returns the new operator returns the address. So PW now has the address, points to this PrintWriter. So what we're going to do is we're just going to use it now very simply, just like we do system.out. So instead of printing to the command line, though, we are printing to a file. So I can say print line and any other method that the system.out object would use. It's just directed to a file instead of the console. So I can say hello there, and then maybe on the next line we'll say just print, and I'll say John Baugh tab, and then Samantha Snuggles tab, and then Holly Oxenfree, okay? And then at the very bottom, we'll actually here, I'm going to put a \n just to demonstrate that I can put the new line character there. And print line, maybe we'll put a couple additional new line characters. Actually, that's going to make 3 because I have 1 generated by this and then 2 more, and maybe 1 at the bottom. So we'll just say file done writing, just to show what we can do with this. And you can pick the format, you choose the format, that's the whole point. You can come up with a particular format that can be arbitrarily complex. It could even be a binary format, but you'd need some different objects for that. But this is a text format. It's very simple. You can come up with the different styles and things like that. But XML and JSON, those would also be text formats. It's text data. And those are very common types. Okay, Java also has different classes to work with those types as well. So let's see what happens. I'm going to actually open up the miscellaneous Java oops, not that. Workdir right here. And then we're going to go into module files methods, and we have our input file that we had from before, but we're going to demonstrate that when I run this, it's actually going to generate an output file. So let's see what happens here. When I run this, right-click, run file, it'll say done because I printed that to the console, but the rest of it is not printed to the console. It's printed to the output stream, which is set to go to output.txt. There you go, right there. We have our statements here with tabs in between, one new line there, and then 1, 2, 3. That was caused by the print line with the 2 extra new lines. So that's 1 from print line and 2 extras right here from new line, and then file done writing, and then a new line at the bottom because it's a print line. Pretty awesome, huh? So that's fairly straightforward. So hopefully that's at least gives you an idea of how you can work with the basics. Next up, again, exceptions, just to review a little bit. With files, we say that there is an exception preventing us from compiling unless we address it. So either we put the throws statement on the method name, or we handle the exception. Checked exceptions must be handled or thrown. That's why when we worked with the file I.O. and it would not let us go on until we acknowledged it, that's called a checked exception. That one prevents compilation. Unchecked exceptions can usually be fixed with just better code. So like out of bounds of array, which we'll see in a minute. The checked exceptions are often out of your control by the time the program leaves your grasp and goes out into the environment. Like a user, if you have an input file that you're expecting and the user moves it or deletes it because their friend told them that would give them extra points in the video game you made or something like that, then the users are notorious for doing stupid things to try to get stuff to work. And also they might download something and something gets corrupted and it just didn't come with the package. Then that's out of your control. So that's why they make you assess those types of exceptions and respond to them. Unchecked exceptions can usually be handled just with better code practice. So we'll get to that in a minute. But first, arrays. So built-in arrays in Java they're first-class objects, so they actually know their own length. You don't have to, if you pass them to a method, for example. It's not like C++ where you'd also have to pass the length as a separate variable or something like that. Arrays in Java actually know their own length, kind of like a class type. They are reference types, so that means even if they hold primitive types, the arrays are reference types. This is how you would create an array in Java. If you're used to C++, notice that even though in Java it's optional to put the square brackets over here, you should put them here. You put them next to the data type. That's the Java way of doing it. If you put it over here, you may end up being put in a dungeon by your Java coworkers. So don't do that. Put it next to int data type. Then you give it an identifier equals, and you do have to use the new keyword with it. So all the arrays are going to be dynamically created. The value in the brackets, this 20 here, can be a variable, constant, method call, whatever, anything that resolves to an integer value. And we will get to the array index out of bounds. And this one, it won't fuss, the compiler won't complain, and it will let you actually run the program without acknowledging the exception. That's because array index out of bounds is an unchecked exception. So let's go back to our code here, and we're going to go to Java class, and we'll call this array fun, and I'm going to do public static void main, and right here, integer arrays, I'll just call it my, ARR for my array equals new, int array of size 5, and then you can access each individual component of the array or index in the array by using, actually they're called cells. The actual things or memory locations inside the array are called cells. They each have an index, and the thing living in that cell, kind of like if it's an apartment in an apartment building, that thing living there is called the element of the array. So here we'll just give it some data, keep it simple. My array at 2 is 37. My array at 3 equals 44. My array at 4 equals 400. Good. So right here, what we could do is you can print out the elements of the array. This is one way. Notice it has a length property, lowercase l, if you're coming from C#. Make note of that. All right, so we'll print this out. I'll say my array at I, right? So I can dynamically access the indices for output, and you can also change the values later. So let's see what happens. If I run this, everything's hunky-dory, goes through the array, everything's happy. Now, if you accidentally happen to put an equal sign there, that is actually going to be the cause of an off by one exception, right? Or an off by one error, which is in this case going to be an array index out of bounds exception, right? So if we run that, we get an exception. Now you can't guarantee it's going to pop up exactly after these. Sometimes it actually looks like it's interspersed here. But you'll notice it tells us it's on line 12. The most recent thing in the call stack says, hey, it happened here somehow. And it tells us it's a java.lang, which is the default package, meaning the stuff you don't have to include, like strings and arrays and things like that. So you've got array index out of bounds exception, and it says index 5 is out of bounds for length 5, right? So that's what happened. It tried to access the array index at index 5, the array at index 5. We can't have that. That's an off by one error. So you might, the question does arise. I already gave you the answer, but the question does arise. Why did this even compile? Because when we had the file not found exception possibility, it didn't compile. It said, hey, you have to put try catch around that. Now, could we handle this with a try catch? Yeah, you could put a try catch around it. But exceptions are good. They're a modern approach, but they're not always appropriate. Sometimes you just fix your crappy code, right? That's what I just did. So I just removed the equal sign, get rid of the bad code. That's not out of your control, like file not found exception. So this is an unchecked exception. Array index out of bounds exception actually inherits in the exception hierarchy in Java from something called runtime exception, ultimately. And anything under runtime exception is unchecked. That's how that works. All right. So next, if we run it again after I fixed it, you'll see everything's nice and happy again. All right. So what happens when we do this? So if you say ARR1 equals ARR2, what would happen if we did that? Does that copy all the elements of array 2 into array 1? Think about that for a couple minutes, maybe pause the video, and just see if you can figure out. Remember their reference types. Do you have an idea? Well, here's the answer. The answer is, remember, whenever you use the assignment operator, you are setting the value of one thing to the value of another. And you have to ask yourself, what is the value of ARR2? Remember that we use the new keyword. So that means we're creating an object and returning an address. So all these arrays live on the heap, and their addresses, since these are reference types, whether you're holding a reference or a primitive is irrelevant. The actual reference of the array object is an address. So what you're doing here is you're copying the address of array 2 into array 1. So that means both of these will point to the exact same array. So if you make a change in one, it will change the other. So as an example, if I make this int bracket your array, and later on, it can be done before or after, it doesn't really matter. I set your array equal to my array. What happens if I set your array at, we'll say 2, instead of the 37, I'm going to put -1000, just so it'll really stick out. So let's see what happens. Now, what are we printing? We're printing my array, but I access this through your array. So let's see, does that change anything? It's still -1000. You modified my array. Because remember, we're both pointing to the same object. It is crucial. This will help you in any other language too. C++, C#, it does not matter. And especially Java in this case, because it's directly applicable. But you have to get it out of your head. You have to distinguish between a reference and the object itself. Okay? These variables, even though we treat a lot of the reference variables like they're the object, So if we have a class variable like the scanner, we call methods on it, and we do stuff to it that makes you think, hey, that's the object. But in reality, it's a reference. It's a reference. If we actually access the value in that particular variable, it is an address. It is not the object. The object does not live in the variable. The address of the object lives in the variable. It seems like I'm really harping on that, but I've had by this point a ton of students come back to me and say, hey, all that stuff we thought you were kind of being overboard with, I got a job because I knew it and the other guy didn't. Okay? I mean, this is the kind of stuff that even right out of when I was out of college and got my first job in industry before starting to work at community college full-time, teaching full-time and becoming department chair there, and just basically teaching most of the time, doing some consulting and things like that. I do that as well. But before I did all that, my first job into industry straight out of college, when I got my master's, one of the major reasons I got the job was because I knew some stuff that the other people being interviewed didn't. And you might think, oh, well, you had your master's degree. Well, some of the people I was up against had PhDs at the time, and I got the job because I knew this stuff, and that was part of the reason. So knowing facts is useful, and it's not just about being able to get through the interview and then you're done. It actually helps you long term. A lot of the stuff that you might think, oh, that's theoretical, I don't really need to know that, it does affect how you code, it affects how you look at it, and it affects your ability to solve very complex problems, especially when there's like an error or some sort of really wacky thing happening. If you start thinking, wait a minute, that's the address, that's not the actual object. There have been several problems I've solved for consulting and things like that because no one else was seeing the problem. And so knowing all this stuff is very, very useful. All right, so let's go back here. Array lists. So array lists, if you're okay, this is maybe a little bit confusing. A generic is similar to class templates in C++ if you're familiar with class templates. So they allow you, the compiler generates appropriate definitions for very specific types. So an array list of strings, or an array list of rectangles, or an array list of what have you. And it saves on you having to do custom coding. It's kind of like, quote, overloaded classes in some ways. But you just write it once, and you can put restrictions on them, but a lot of times you don't have to. And the array list type is offered to us, and we can put pretty much any type in it as long as it's a reference type. So it has to be a reference type. Now, the array lists themselves, if you're looking for something corresponding in, say, C++, they're very similar, not exact, but they're very similar to a vector in C++. So if you know the vector type from the standard template library in C++, then you would know array lists. Really, the only difference here is it's the list abstract data type implemented with a dynamic array. So this one, unlike the regular array, which when you create it, the object cannot be modified, its size cannot be modified once you create it. With a regular array, what happens if I need to make it bigger? Well, I'd have to create a new object, hold its memory address, copy the items over, and then point to that new object and let the other one be garbage collected, the other reference to be removed at least, or set to null. So, yeah, I guess if it's got something pointing to it, it wouldn't get garbage collected, but you want the other reference to just not point to anything. So that's how you would do it if you had to implement it, but they've done it for you. It's very nice. Just like vectors in C++. You can add items as needed. You basically just add them. And the restriction is, though, that it only works with reference types. So let's kind of take a look and then see what we can do if we need it to work with primitives. So is there a way around it? So we'll say array list fun. Okay, array list fun, array list challenge, doesn't matter. Java.util.ArrayList, right there. Public static void main, end main. I'm going to say array list of strings. Since that's a reference type, we're good. We'll say myAL equals new array list, and as of newer versions of Java, you can actually leave this part blank. You used to have to fill it in with whatever this was, so you would kind of do it twice. But now, since they know that this is a string type. They know that this needs to be string as well. Now, what do I do? MyAL.add. I'll add some names. Bob. Add Ksenia. Okay, and then Sally. All right. And we can, of course, loop through them, just like we would regular array. It's a little bit different. MyAL.size instead of length, and it's a method. Okay, instead of a piece of data. Okay, that's one way to do it. And we'll just say myAL, and then here's how you access them. You have to say get, and then the index. All right. So if you need to set myAL.set, you can set at a particular index a new element. That's how you overwrite what's currently in there. So this should be pretty straightforward. This is about what we did with the regular array, so let's give it a shot. ArrayList fun. And of course, we do get John, Bob, Ksenia, and Sally, as expected. And the other thing I said was, what happens if you need integers? I can't do this. My int al equals new ArrayList of whatever type. Give it a second, and we get a big red line. Unexpected type. Required reference, found int. So that's telling you that this thing cannot handle primitives. So that seems really, restrictive. Well, you can actually use corresponding wrapper class called integer. We'll get to those in just a minute. But now I can just add them like that. So you might think, oh, so I can just do this, .add, and then say new integer, like 15 if I want to add 15. But you'll notice that even the IDE hates me. It's saying unnecessary boxing. That means you don't have to put it in an object. It knows to do that. So the wrapper classes, are one of the rare exceptions that Java lets you get away with. It'll take care of the effort of converting a primitive to a reference type. So I've added 15. If I want to get it back out, my favorite int, I can say my int al.get, and I'll get index at 0, and I can print this out, my favorite int, and then say my fav int, just to prove that this does get the 15 out, and it does in fact work, right? So that's called, this part right here, it turns a primitive, automatically puts it in an object for you, and then stores the object. That's called auto boxing. And then when you can get it back out without having to do a conversion or anything, it knows that even though it holds integers, that you want a regular old plain int. So this is called auto unboxing. Pretty cool, huh? So let's go back to here and talk about the wrapper classes. There are 8 wrapper classes. Each corresponds to one of the primitive types. Remember, our primitive types, same thing here. We have byte, short, int, long. With the wrapper classes, there's byte, short, integer, long, and then float, double, char, boolean have the corresponding float, double, character, boolean. The only differences are they're all capitalized because they're classes. You should capitalize your classes. These are all capitalized, and these two right here, integer and character, are spelled out. So anytime you need to use a primitive inside of something that's a generic, like ArrayList, ArrayList is uses generics, and it's actually a data structure. So because it's a container of other elements, that's what a data structure is. A data structure is a container of other elements. It contains other elements. The most primitive data structure, let me not use primitive because that means something to us. We'll say the most simple data structure that we have at our fingertips is the built-in array. But ArrayList is an implementation of the list data type the list abstract data type using an array behind the scenes. So it builds up on that and then gives us this beautiful data structure. All right, so if you ever have to use the primitives, you use the corresponding wrapper classes if you have to use them with one of these generics like the array list. There's also the enhanced for loop. It works with arrays and array lists. So let's see how that would work. We can comment this out, control / with it highlighted. I'm going to do this since it contains strings. This time you don't go based on the index type, which is always an int. You go based on what kind of data does it have inside of it. In this case, my AL has strings, so I'll say string name and then colon my AL. And then you are basing it on the elements in there. So I can just say, well, print out the name. Okay, let's see if it does the same thing. And in fact, it does. No difference. This is what we call syntactic sugar. I usually don't count it as a, quote, separate for loop. So when you ask me how many repetition control statements there are, I would generally say 3, while, do while, and for, but I would put a caveat and say there's an alternative version, the enhanced for loop. So if you're ever in an interview, you could say 4 and tell them why, or you could say 3 and say, but there's also a variation on the for loop, and just say that your instructor told you that he didn't count it as a separate one. It's really behind the scenes. It acts just like a regular for loop. It's just you cannot get an out of bounds exception with this type of for loop. So that's called the enhanced for loop, right? C++, if you're coming from there, does have something similar. It's called a range-based for loop. So just a little bit tidbit of information. Methods. So up next, this is our final major topic of this particular module. Classes, starting at the class level. Classes, of which everything's inside in Java. If you haven't noticed already, unlike some languages that are like object-aware, like C++, you cannot have anything really outside of a class. There's interfaces, but we'll get to that later, and enums. But in general, everything lives inside of a class. You can't have a method outside of a class, like a regular global function. There is no such thing in Java. There's no such thing. There's also no such thing as a global variable. We have fields, which are data that lives inside of a class, and you have methods, which are the behaviors. When we get to really getting into object-oriented programming in a different module, we will really get into that particular topic a little bit deeper. But methods, the behaviors, and fields, the data, fields and methods are what is encapsulated when we talk about encapsulation in classes. So you can move that single entity around, the object, which is an instance of the class. You move that around, and it behaves like a single entity, but it could have multiple fields and many different behaviors as well, methods. So how do we classify methods? Well, one or a couple different ways to classify methods, there's others, but a couple different ways to classify them is by whether they have a parameter or not. So they're either parameterized or parameterless, right? So if it's got at least one parameter, it's parameterized. If it has no parameters, parameterless. And it could be value returning or void. So that's another option. So terminology-wise, is there a difference between parameters and arguments? Yes, and if you are taking one of my classes, you better know this very well for your tests. So parameters, a parameter is the placeholder in the method definition. And it will take on the value that's passed in. Okay, so it basically, the value that you pass in as the argument, when you call it, goes into the parameter. You get a copy of whatever the value was. And then that parameter takes on that value, and it basically acts like a local variable to that method. An argument, as I alluded to, is the actual value, variable, constant. It could be a method call, whatever, anything as long as it resolves to the type of the parameter. The argument is what's actually passed in when the method is called. So there's your key right there between the two. Parameter is the placeholder in the definition, and then an argument is when it is called or used. I'll give an example right here. Let's create another class called method joy. Okay, got tired of fun, so we'll do method joy. Okay, there's our method right there. Without getting too much into the nitty-gritty, we'll make another public static. We'll talk about static and all that stuff in another module. But for right now, just put public static, and now we'll worry about the main, or the method's return type and such. So in this case, we'll do int square, and it takes an integer n. All right, so n square, and we can just return n times n. Okay, so this one would be a parameterized value returning method. Get used to using the term method instead of function, because a method, the distinction is that a method is a function that lives inside of a class. And since all quote-unquote functions in Java live inside of classes, they're all methods. In C++, a lot of people use the term member function, but the term method is catching on a little bit more too. Method means functional component like this that lives inside of a class, and they all do. So call it a method. So this is a parameterized, and it's value returning. If I ask you specifics, you would say it has one parameter, an integer, and it returns an integer, which is the square of its parameter. The parameter is the placeholder. So this is a parameter. Up here, if I do this, int my num equals square of 5, that right there is an argument. So in this case, we would say 5 is the argument. Okay? In this case, it's a literal constant, but I can also do this. Int my other num equals square of my num. And then that, in this case, this, even though it's a variable, that's also an argument, right? So my num is the argument. And we'd say n is the parameter in that one. And what else? So we've got, do another one here. We'll say another num equals square of 2. So we can do that too. So we would say the 2 is the innermost parameter, and then the return value of this call acts as the argument to this call. So you can do that, as long as it resolves to the type that it's looking for, which in this case is an integer. And all three of these pass integers in. Pretty cool. Let's print them out. My num is my num. We can do my other num is my other num. And then, of course, another num equals another num, right there. And let's run it. So method joy run file, and it gives us pretty much what we expect. So my num is 25. We end up with 25 squared right there, and we end up with 2 squared squared. So 2 squared is 4, so that's what this returns. And then the 4 is passed into the square, and that gives us 16. Do it again. Let's do it again. You can do it 3 times. If you do it again, then that will end up with, what, 256? Right? There you go. Pretty cool. So that's pretty awesome. Can you pass in arrays and stuff to methods? Absolutely. So if I want to pass in an array, so or array list even, but let's say some array equals new int of size. We'll just make it real small. I'll say some array at 0. We'll mix and match some things here. We'll square 22, and then some array at 1 is the square of, well, let's see here, 10. And then I'll make a nice little method down here, public static void, and this one will say, we'll call it print array, and it takes an int array called int arr. You do not have to pass in the size separately because they know their own size, and we'll just help ourselves here and use a range-based for loop, right? Or the enhanced for loop, rather. So we'll say this time it's the type. So int num inside arr, and we will print out num. All right, so that's the parameter. It is a void parameterized method. And then let's go up here and call it. So we'll say print array, and I'll print array on some arr, and maybe put a couple spaces so we don't get it mixed up with the stuff we already worked on. Run it, and there you go. We've got our 2 values here, and then the other stuff down there. Maybe that's a little too much. Run it again. There we go. A little less space. There we go. Pretty cool. And so is this pass by value or pass by reference? And the answer is everything in Java is pass by value. So there's no pass by reference like there is in C++ or even C#. C# actually has different variations on it. But you have to remember there are two categories of data types. When either a primitive or reference is passed to a method, its value is copied from the argument into the parameter. But, now remember the value is copied because it's passed by value. But what's the value of a primitive? That's just the value. So that's effectively passed by value. But what's the value of a reference? It's an address. So that's effectively passed by reference in some ways. So you're actually passing a reference to it because a reference type has an address. So the parameter will obtain the reference, the address, and therefore it will refer to the same object as the calling method rather. Right? Pretty good. Another term you need to know to prepare for the future is method binding. So this is really important for understanding OOP better later on and also for just understanding methods. Note that binding refers to the association, not reference. Binding refers to the association of a method call with a method definition. Now remember, we've made the distinction before. Method call has the argument, method definition has the parameters, right? So when it is associated, when that call says, oh, I'm talking about that definition that I need to load into memory, that's called the binding. In Java, final, private, and static methods have static binding or early binding, which occurs at compile time. C++ has all static binding by default. All other methods have dynamic binding or late binding, which occurs at runtime. In C++, the only way to make that happen is to use virtual functions in C++. But in Java, it's automatically dynamically bound. So remember this and repeat these facts on this page, and in fact in the entire lecture, but in this page specifically, this slide. Repeat them to yourself multiple times before bed every night for the next couple weeks. That's your prescription. Trust me, I'm a doctor. Kind of. All right, I will see you next time.